Hello again. We are on a roll, just crushing out worksheet after worksheet here, folks. So in this particular case, you had 6 problems for density to solve using your density equation and having to manipulate the equation or rearrange the equation to solve for either mass, volume, or density, which, based on the note set from this particular day's lesson, you should be able to do and will be an expectation that you are able to do. So let's just jump right in here. This first one here, if we are solving solely for density, we are going to take mass and divide it by volume, right? So in this particular case, I am just going to go ahead and take my 54.0 grams, and I am going to divide it by my 20.0 cubic centimeters. And when I do so, and this comes to be 2.7 grams. Oh, that is not what I was expecting to come up there. Per cm. Now, if you can't do the subscript or superscript, you can go caret, which is shift 6 and a 3. So that's the same as raising centimeters to the third power. It's actually an easier way to go about just typing everything in. And so this is our final answer. Let's just go through and highlight that. Boop. Yes, sir. All right. And this next one here, again, we're trying to figure out volume, right? The first one we were figuring out density. This one's figuring out volume, and volume is actually equal to mass divided by density. You'll notice that in manipulating this equation, mass, if it's not what is trying to be found, remains on the top. It's always the first number in the calculator to be divided by either volume or density, depending on what you're solving for. Just a quick trick. So in this particular case, I'm going to take my 16 grams and I am going to divide it by my 4.0 grams per milliliter. And that is going to give me my density, which 16 divided by 4 is 4.0, and my unit for volume is milliliters. So this should have been your final answer. Now I'm trying to discover the mass. Okay, here's where the type of math we're going to do will change. In this particular case, if I am looking to solve for mass, I would simply take my density and I would multiply it by my volume. So the other two variables within this equation are going to be divisions, with mass always on top. But when you're solving for math itself, with mass itself, you need to do multiplication, okay? So just trying to think of ways to help you remember this. So the density of this particular unknown substance was 10.0 grams per milliliter, and I am going to go ahead and multiply that times the volume, or the space the object occupied, and that was 80.0 milliliters. And when I multiply those two variables, I'm going to get 800, and the unit for mass is grams. And there you have it, folks. Boop. Doo-doo-doo. Now, in this next particular problem, you had to draw a picture, which, if I were to represent these in some sort of column, right, because they're in a large beaker of, are placed into a large beaker of water, okay, so the water is going to be in there. So we have to take account what is going to happen in terms of the density of the water. Are these objects, styrofoam, ice, bone, balsa wood, and gold, are these solid objects going to sink or float? And where are they going to sit within this large beaker of water? So what I'm choosing to do is, since there are 5 objects, 1, 2, 3, 4, 5, yep, I'm going to go ahead and insert a little table that's just going to go 1, 2, 3, 4, 5 down like that. And I'm going to shrink this bad Larry right up, boop, so that I can just go, okay. The for sure sinker in this particular case is going to be the most dense, and so that is going to be object E, right? Because object E has a density of 19.32 grams per cubic centimeter. And from there, I would just start listing them in decreasing densities as we're moving up the column. If you prefer to go from the lightest or least dense, I should say, object on top, that's fine. So let's see, that took care of this right here. So let's see, what would be the next one? Well, I think that would be object C, because it has a density of 1.70 grams per cubic centimeter. So both of those are definitely going to sink within the column. And let's see, the next one would be object B, which I believe is ice, slightly less dense than regular water. Object B is going to start to be floating more readily. What did I say? Object B. And object B had a density of 0.92 grams per milliliter, followed by object D, which is also, oh, those are my dogs, I know. Hey, trying to make a video over here, huh? Can you take it down a notch, buddy? Yeah, that's good boy. So object D, which has a density of 0.05, and there they go again. What is it? That's styrofoam. Sorry. Object D, balsa wood, 0.16 grams per cubic centimeter, followed by also floating on the top, which would be our styrofoam. Object A, 0.05 grams per cubic centimeter. So hanging out in the column of water, you would have styrofoam floating very close to the top, on the very top of the water. Your balsa wood floating just barely lower than that. Then you would have ice floating a little bit lower than that. And then the other two objects you would see very much at the very bottom of the column. So if this represents just putting them into their the column, so listed by density, you can start to think about what is going to be happening. And then we have the last problem, and it's two-part, right? 5 and 6 go together, because the first thing you have to do is find the volume in this particular problem. Now, volume in this problem is being found using water displacement. So volume is going to be where the volume rose, so 30.0 milliliters, minus where it initially started, which was at the 22 milliliter section. And that is going to tell you the volume of the object. Why did that move over? There we go. So the volume of this object is the difference between the starting and ending point once the object was placed into the graduated cylinder, which means this is 8.0 milliliters. Okay. Now, number 6 goes with this, because we're saying what is the density then of the object in problem 5? And so if we were, using the volume that we got in number 5, we then have to also use the mass of the object from number 5. And again, since density is equal to mass divided by volume, we very simply are taking our 24.0 grams per cubic grams, and then dividing it by the 8 milliliters that we found the object to take up for space, and we are saying that then this object has a density of 4.0 grams per milliliter, and this is the final answer. Okay, and there we have that. And I hope that this is helpful, and boy, oh boy, I've got to find a way to make these videos a bit shorter. Feel free to speed through them at your leisure to check your answers. Thanks, have a great day.